Hey everyone, welcome back to the YouTube channel Developers and Coders Club. Today we are here to discuss the problem Vika and price tags, which is a part of recent contest of Codeforces round 885. So in this question, we will be given two arrays. One is A, another one is B, and we need to perform an operation. And that operation is that we will construct a new array C, and ith element of this array C will be equal to AI minus BI, absolute value of AI minus BI. Now, after this operation, what will we do? We will make array A equal to array B. That means whatever the values in B, that will be equal to array A, and array B will be equal to array C. So basically, what it means that uh, in this example, 1, 2, 3, 4, 5, 6, 7, and the B is 7, 6, 5, 4, 3, 2, 1. So in this one, C will be 7 minus 1, that is 6. Absolute value of this is 4, 2, 0, 2, 4, and 6. Now after this operation, B A will be equal to B and B will be equal to C. This was B, that means this will be A now. And this was C, that means this will be B now. Then again our new array C will be 7 minus 6, that is 1, 2, 3, 4, 1, 2, and 5. Okay. So this is how we are going to perform the operation. Now our task is to determine that uh, this is given that Vika decided to call a pair of arrays A and B dull. If after some number of such operation, all elements of array A becomes 0. So basically we need to find that is it possible to make all elements of array A equal to 0. If that is possible, then we will print yes, otherwise we will print no. So just consider a array like A1, A2, A3, A4, A5. Okay, let's take the array which was given here. That was 1, 2, 3, 4, 5, 6, 7, and 7 to 1. Okay, so 1, 2, 3, 4, 5, 6, 7, and 7, 6, 5, 4, 3, 2, 1. Now just think that after some operations, we got that this element equal to 0. Maybe this is not equal. Maybe this is 1, this is 2, this is 4, this is 3, this is 2, this is 1. But we know that here 2, 2, 0. Such type of condition we got. So, like I want to say that after some operation on this index, we got 0. Okay. Now, after that, we perform again one operation. So, that will be now this is making something, but this will be again 2. That absolute value is 2. Then we perform again new operation. So absolute value that is 2. Then we perform again new operation. Now that is again 0. What I mean to say that if anywhere you are getting 0 on any like kth operation, then after k plus 1, 2, 3. Then after k plus 3th operation, you will again get 0. So from this idea, we can say that we just need to find that ith element uh, ith element of array A on which first operation that will be equal to 0. What I mean to say that like this one is getting 0 on, just suppose that this is getting 0 on kth operation, then this element first element that is getting 0 on lth element, and the second element that is getting 0 on mth element, mth operation. Okay. Now, what is our condition? That we need to make all elements equal to 0. That is our target. So for that, we know that if this is getting on kth element that is 0, then on k plus third element, third operation, that will be again 0. If this is getting on alth operation that is getting 0, then definitely On al plus 3th operation, that will be again 0. And same for this one. So what is the relation you are getting from it? Can I say that um, the remainder from like k percent 3, k mod 3, al mod 3, m mod 3. If this is k mod 3, this is like c1, then obviously k plus 3 mod 3, that will be also c1. Same for this one, same for this one. Which means I want to say that for all elements, for all indexes, if you are getting like k on k1th operation, you are getting this equal to 0. On k2th operation, you are getting this equal to 0. On k3, on k4, on k5. So for getting all elements equal to 0 on same operation, the one condition which is needed, that is the remainder k1% 3, that should be equal to k2% 3, that should be equal to k3% 3, so on. So like if you want to, like I make, one second, what is that? Yeah, like while solving the question in context, what I did that I make first or array A is this or array B is this. So I calculate the difference and so on. I getting the new array C and making A equal to B and B equal to C. From that I got that I'm getting like this one. I'm getting 0 on this operation. Then I'm getting again 0 on like what is this operation? It is first, second. Then I'm getting again 0 on fifth operation. Then I'm getting yeah. Then I'm getting again 0 on 6, 7, 8th operation. So remainder of this is 2, this is also 2, and this is also 2. So if you want to make all elements equal to 0, then the condition which you need to follow, that the first operation, where you are getting the element equal to 0, and remainder of that should be equal for all indexes. You can see from here that like this is 0, then you are again getting this on this operation 0. On the same operation, you are getting these equal to 0. Then like this is not yet 0. But when you are getting again these equal to 0, on the same operation, you are getting this equal to 0. So the one and only condition which need to follow is the first operation on which ith element is getting 0. The remainder of that operation with 3 should be equal for all indexes. Okay. Now what is our now task that we need to find, like uh, now we don't need to process for all elements. What I am saying that just think array of I, this is a is this, not take a, let's take it x is equals to array of I and y is equals to the second array of I. Now our task is to find the first operation on which x will be equal to 0. What will we do? Uh, this is element of A, this is element of B. Then C will be equal to mod of x minus y. Then again x will be replaced with y and y will be replaced with x minus y. So we need to find that on which element, on which operation this x will be 0. And we need to find the remainder, like we are getting on 10th operation, we are getting that equal to 0. So we will calculate the remainder with 3 of that, and we will check that the remainder of all indexes should be equal. Okay. Now what we have x and we have y. Now our target is to find the remainder of that operation with 3 What I'm saying that remainder of that operation with 3 on which operation we are getting 0. X is equal to 0. We need to find the remainder with 3 of that operation. Okay. Now just tell me that if X and Y we have, there can be two possibilities. Either X can be less than Y or Y can be less than X. Okay. If this is, then our new X and Y will be Y will be this and Y minus X will be this. What I am doing, X and Y, these are the values initially. Then we are saying that A will be equal to B, which means X will be equal to Y and B will be equal to A minus B. That means Y will be equal to X minus Y. So the step which we will be get after this option, that will be Y and modulo of X minus Y. So for this absolute value, I am saying that there can be two conditions, either Y minus X or that can be Y and X minus Y. Is it right? Then for this one, there can be two conditions. This will be X and there can be two conditions, either Y minus Y minus X or Y minus X minus Y. From this one, we are getting Y, I can say that is X. And from this one, we are getting minus X. So minus X, because we are taking absolute value, so minus X will be equal to X. So that will be X. And for this one, we are getting same thing. Y minus X, like what I am saying. From this one, we are getting X. And for this one, we are getting minus X. But as we are taking absolute value, so that will be X. So both are same. So let me write. Okay. Uh, let me remove this one because we are getting same step. For this one, X minus Y, X minus Y minus Y, that is X minus 2Y. X minus Y, Y minus X minus Y, Y minus X minus Y. So that will be plus. So 2Y minus X. Okay. For this one, this X will be here. Y minus X minus X, that is Y minus 2X. And this will be X and that will be negative of this one, that will be 2X minus Y. For this one, X minus 2Y, X minus 2Y minus X plus Y. We are getting minus Y. Absolute value, that is 1. And from this one also we will get same. So we don't need to make, because both are same. From this one, we will get X minus Y. Okay, sorry. 2Y minus X and 2Y minus X plus Y. So that is 3Y minus 2X. And for this one, 2Y minus X, 2X minus 3Y. So I think this will be enough. Now just tell me that this is zeroth operation, this is first operation, this is second operation, this is third operation. Okay. Now what is our target? We need to find that on which operation we are getting this equal to 0, this equal to 0, because this is the value of X. Okay. So we can say that if X is 0, if X is already 0, let me remove it. We can say that if X is already 0, then that will be on zeroth operation. our operation will be zeroth operation. Okay. What we are doing, we are finding date operation. We are finding date operation, remainder of date operation on which operation x will be 0. Okay. Uh, then for this one, we can say that if y is equal to 0, then on first operation we will get our remainder of y equal to 0 because y that is x in this case in on our first operation. So operation is 1, remainder of that with the 3, that is 1. So this is the value of remainder and these are the conditions. Like for this remainder, this condition should be. For second, for remainder is 2, what are the conditions? That are the x should equal to y. Because what are our task? This should be equal to 0. So x should equal to y. This is also saying same, x should equal to y. And this is also saying x should equal to y. On our third operation, what will be the remainder? 3%, 3 that is 0. So that is pointing to same this one. On our third option, the conditions are saying that either x should be equal to 0. This is saying that x should equal to 2y. This is saying same thing, x equal to 2y. And this is also same. So these two conditions are followed by the third operation. So x equal to 0 we have already written. Why I am writing in the 0? Because this is the remainder with 3. So x should be equal to 0. And the second condition is x should be equal to 2y. Okay. So we need to construct two more rows. For that, let me remove it. Okay. Now for this one, y minus 2x or x minus y plus 2x. That will be 3x minus y. So this will be y minus 2x and y minus 3x. This one will be 2x minus y and 2x minus y minus x. 2x minus y minus x. That will be x minus y. And this one will be 2x minus y and y minus x. Okay. For this one, this will be y x minus 2y minus y. X minus 2y minus y, that is x minus 3y. Or this can be y and 3y minus x. Now for this one, this is 3y minus 2x. 2y minus x minus 3y plus 2x. So this will be x, this will be minus y. X minus y. And the same will be 3y minus 2x and y minus x. And for this one, that is 2x minus 3y and 2y minus x minus 2x plus 3y. That is 5y minus 3x. 5y minus 3x. And the second one will be 2x minus 3y and 3x minus 5y. Okay. Now we have considered from here. Now this is the fourth operation. This is the fourth operation. What it is saying that what are the conditions on which x will be 0 on the fourth option. So the conditions are y should equal to 2x, either y should equal to 2x or the same is there, same, same, y equal to 0, same, 3y equal to 2x, 3y equal to 2x, 3y equal to 2x, 3y equal to 2x. So these are the three conditions, which is saying that if these three conditions are followed, then on the fourth operation, our x will be equal to 0. And if that is on fourth operation, then remainder of that will be 1. So I can add these three conditions in our 1. So where is that? Okay, yeah, this is it. So let me 1 minute. Okay, now on our first we can add these three conditions. So y is equal to 0, that is already here. Y equal to 2x, and another one is 3y equal to 2x. So I'm not going to make the another steps, because you all know that on the next step this one will be here. On the next step this one will be here. So we don't need to write the next step. We can proceed with this. That means that on fifth operation, the x will be 3x minus y. If that should be equal to 0, that is saying that 3x should be equal to y. 3x should equal to y. 3x should equal to y. X should equal to y. X should equal to y. X should equal to 3y. X should equal to 3y. X should equal to y. This is 3x should equal to 5y. So that is 3x should equal to 5y. So we can add these three conditions in 5 percent 3, that is 2, in this. So there will be x is equal to y, that is already here. So 3x is equal to y and 3x is equal to 5y. So this is the data from which we can get our answer. How we are getting? Like, can you see some pattern from this one? On the second operation, not second operation, on those operations from which we are getting remainder is 2. For those, the one condition we can see that, like I'm saying, that x equal to y. Let's assume it m. Let's assume it n. This is the general term for these all. So for this one, you can see that for all conditions, m is odd and n is also odd. M is 1, n is 1. Both are odds. M is 3, n is 1. Both are odds. M is 3, n is 5. Both are odds. So I can say that if remainder is equal to 2, so for that the sufficient needed condition is m percent 2 is equal to 1 and n percent 2 should equal to 1. For this is remainder equal to 2. For remainder equal to 1, you can see that for this one n is odd and m is even. What I'm saying? N is odd, this is odd, and this is even. N is odd, m is even. N is odd, m is even. N is odd, m is even. Notice here that y is written before x. Okay. So for remainder equal to 1, n should be odd and m should be even. And for remainder equal to 0, m should be odd and n should be even. M should be odd and n should be even. M should be odd and should be even. So this is the main key which we got from these all. Okay. So notice these three conditions. For remainder is equal to 2. These these two conditions should be true. For remainder equal to 1, these two. For remainder equal to 0, these two. So, for once, let's summarize what I was saying. First of all, I said that if I'm getting on kth operation or ith element equal to 0, then I'm sure then on k plus 2 threeth operation, I will get again that equal to 0. So, from that, I can say that if remainder, like if op- mm, the k is the operation on which we are getting the remainder first times a equal to 0. A is the like ai is equal to 0. Then the remainder of k percent 3. This should be equal for all elements. Okay. So after that, our target was that for every indexes, we need to find that first the remainder of the first operation with 3. We need to find the remainder of the first operation with 3 on which operation we are getting 0 on AI. Okay. So our target is to find the remainder for every indexes. Okay. So for that we do this. We do this. From which we got that if a remainder is 2, then also both like x and y. X is ai and y is bi. So if I am writing this as m dot n, then if remainder is equal to 2, that is saying that m percent 2 should equal to n percent 2, that is 1. If remainder is 1, that is saying what is that? If remainder is 1, then n should be odd, m should be okay, yeah, n should be odd, m should be even. And if remainder is 0, then m should be odd and n should be even. Okay, clear. Now after that, one step, and that is last step, that is that m dot x n dot y. How to find these m and n? Like if I say that 10 and 15, if you want to make both equal, both step equal, so what should be the value of here? What should be the value here? So can I say this should be 2, 3 and this should be 2? 3 into 10 that is 30 and 2 into 15 that is also 30. And you cannot make more small value from this one. Like this is also true, but these are the smallest value. Okay. So how to find this one? That is the 10 and 15 is here. So multiply this with 15, multiply this with 10. Divide this with GCD of 10 and 15. Divide this with GCD of 10 and 15. So this GCD of 10 and 15, this will be 5. This is 3. This is 2. So now what I am going to say, the traverse for complete array, find the value of m and n for every ith element. Check that which remainder that is giving. Is that is giving 2, is that is giving 1, is that is giving 0. And check for that for every indexes, are we getting same remainder? If we are getting same remainder, then print yes, otherwise print no. Okay, so now let's see the code. Um, this is the GCD. Then I'm taking input for array, first array and second array. Then this is the set. Why I'm using set? That is just for checking that are we getting only one remainder? Like there should not be like on some index we are getting remainder as 1 and on some indexes we are getting remainder as 2. So I will insert all remainders in HT and I will check that HT size of HT should not be more than 1. Now if array of y is equal to the first element of first array, that is equal to element of second array, that is pointing to where is that? Yeah, if both are equal, x equal to y. So we can say that this is 1, this is 1, that means both are odd. So from this one, that should be followed condition remainder is 2. But I written a continue. Why? Because if that is 0, if both are equal, but the element is 0, so I can say that that is following remainder is 1 also, that is following remainder is 2 also, that is following remainder is 0 also. Why? Because if both are 0, then all operations that will be 0. So I'm not inserting any value because that is true for every operation. Now if that is both are equal, then we need to insert 2. If array of I is equal to 0, why I'm taking this condition out of this? Because if that is 0, then that will be difficult to find the GCD. So if that is 0, then I'm inserting 0. Why? If array of I is equal to 0, so I can say y equal to 0. So n is odd, m is even. N is odd, m is even. So we need to insert 1. Array of y is equal to 0. So okay. So y is equal to 0, that is not x equal to 0. So we are inserting 0. And in other case, we are inserting 1. Here we are getting the x and y is m and n in our this. So value of an m will be the other element divided with GCD, and same for n. If both are equal, like I'm not saying that the remainder should be 1. Why? Because if remainder both are 0, that cannot be. Like what I want to say, that this cannot be that value of m is 6 and is 4. Why? Because if that is, then this will be cancel out, that will be 3 and 2. Because we are finding the smallest value. So if both remainders are same, that will indirectly point out that both are equal to 1. So in that case, we will insert 2. In other case, we will insert 1. And in this case, we are inserting 0. That is followed by these conditions. Where is that? Yeah. So you can pause here and you can see that what are the conditions. If remainder is 1, for remainder 1, n percent 2 should be 1. For remainder 0, percent 2 should be 1. For 1, n. For 0, m. So if in final the size of set is not more than 2, then we'll print yes, otherwise we'll print no. So that's all about this question. I hope you all understand it. See you in the next problem. Till then, happy coding. Bye bye.